I have to solve this integral e to power minus x square over the interval 0 to infinity. This is also called gamma function. Now let's suppose that if I take this integral as g, and if I say that if I take another integral g, that is 0 to infinity, and I just flip the signs and I take I say that e to power minus ay square into dy. Now if I multiply this equation, this integral 1, this is integral 2. If I multiply this integral 1 with this integral 2, I get g square over the interval 0 to infinity e to power minus x square into e to power minus ay square dx over into dy. So this is simply a double integral. Now just you can see e to power minus x square, e to power minus ay square. My bases are same. Whenever your bases are same, you just need to add the exponents. If I solve this and I add the exponents, what I'm getting is 0 to infinity e to power minus a into x square plus y square into dx into dy. So now you can see that we have a Cartesian product system, that is simply this. This is my coordinate 1, this is second, this is third, this is fourth. So if I take like an r over the interval 0 to infinity, and this is my x over infinity, this is y over 0 to infinity. If I take an r and this is a theta, if my r varies from 0 to infinity, by Pythagoras theorem, I can say that r square is equal to x square plus y square. This is my base square, this is my perpendicular square, and this is my hypotenuse square. So this is simply a Pythagoras theorem. Now if I solve this for theta, I will get dx over dy is equal to r into d theta. So when r approaches from 0 to infinity and theta goes from 0 to pi over 2, I just need to plug in these values into this double integral. If I plug in the values, that I'm getting is I will just like simply plug in the value, that is 0 to pi over 2, and here I will get d theta, and 0 to infinity, here I will get e to power minus ar square. My ar is simply x square plus y square minus a is this, and here I will get simply r into dr. So now you can see that this is really simple. We need to solve d theta over the interval 0 to pi over 2, and this e to power minus ar squared r dr over the interval 0 to infinity. Now I can use my u substitution method, and I can say that u is equal to ar square. Now if I take derivative of this u, I can say that du over dr is equal to 2ar. So if I just plug in the values and solve this equation or this integral, what I'm getting is 0 to pi over 2 into d theta into 0 to infinity into e to power minus u du over 2a. So this is really simple. Now just you need to solve the integral. Here I'll get theta, and here you will get e to power minus u. So here I'll get theta over the interval 0 to pi over 2, and here you will get e to power minus u, and you have to just add a minus sign, as you need to take the derivative in the denominator as well. So I will get minus e to power minus u over the interval 0 to infinity. Now if I plug in the values of this upper limit minus lower limit, this is simply a basic formula, you must know about that, and what I'm getting is pi over 2 minus 0, and this is simply minus 1 over 2a, that is e to power minus infinity minus e to power 0. So as I know that e to power 0 is equal to 1 and e to power minus infinity is simply equal to 0. So what I'm getting is simply pi over 2 minus 1 over 2a, and this is simply minus 1. So if you multiply pi over 2 with minus 1 over 2 with minus 1, you will get pi over 4a. So this pi over 4a is simply equal to g square, that we initially assume that g square is equal to, simply when we multiply those two integrals with each other, we got a double integral, and we solve the double integral, and we are getting this g square is equal to pi over 4. Now to find the value of g, that is simply my this is my g, that is that I initially assume, that is this is my g. So to get the value of g, I will just take the square root. So g is equal to pi over a root into 1 over 2. So this is how you solve such integrals.